So, we're going to talk about a totally revolutionary shift in artificial intelligence today. It's all built on this one single kind of brilliant idea. What if, instead of just feeding an AI old data, you could cast a billion digital actors to help it write its own scripts for reality?
You know, it all boils down to the most basic question in the whole field. It's the question every lab, every developer, every single company is chasing. How do we make these things more capable, more intelligent?
For years, the answer's been pretty straightforward, kind of brute force, really. Just feed it more data, shovel in the entire internet, every book ever written, every scientific paper. The thinking has always been more data equals a smarter AI. Simple. And that, right there, leads us to the big problem, the one that's keeping AI researchers up at night. We're literally scraping the bottom of the barrel. We're getting dangerously close to the point where we have fed AI all the high-quality, human-made data that exists on the public web. So, what happens then?
Okay, think of it like this. A large language model is like an actor. It needs a script, that's the data, to learn its lines, to learn how to perform. But the world is running out of new, original scripts. We're hitting a creative wall, and the old ways of trying to write new material, well, they just haven't been working.
People have tried to solve this before, of course. One method was basically like asking an actor to just rewrite old scripts. You get slight variations, sure, but nothing truly new. Another approach was like giving them a checklist of topics, talk about this, then this. That only really works for super narrow subjects like math problems. Neither of these could generate the truly diverse, massive amount of data that we need.
And this is where the idea gets so incredibly cool. Instead of trying to force the AI to write new scripts from scratch, what if we could create a massive cast of digital actors, or personas, and have them generate the data, each from their own unique point of view?
This whole concept is called persona-driven synthesis. At its core, it's just teaching an AI how to role-play. So instead of just answering a question, it answers it as if it were a specific character. A physicist, a musician, a historian, you name it. Each one of those personas unlocks a completely different slice of the AI's hidden knowledge.
And the way they create these personas is just, it's so elegant. It's a simple three-step process. First, you grab any piece of text from the internet. Second, you ask the AI a very simple question, who would read or write something like this? And third, the AI just generates a super detailed specific persona based on that text. That's it. It's that simple.
Let's look at a real example from the paper. Here we've got a really dense technical chunk of a paper about room temperature superconductors. Pretty niche stuff.
So the next step is to just ask that question. Who is the kind of person that would be writing this, or reading it, who would be interested in this very specific text?
And boom, look at the result. The AI figures out an incredibly specific persona. It's not just a scientist, it's a condensed matter physicist specializing in superconductivity. Now imagine doing this process with trillions of words from all over the web. You can generate a practically infinite number of these unique, super detailed personas.
And this is where the scale of this project just becomes mind-boggling. The researchers at Tencent didn't just make a few thousand of these. They created what they call a persona hub with 1 billion of them. A billion unique personas. That's a cast of digital characters equal to about 13% of the entire world's population, all ready to generate new data whenever you want.
Okay, so we've cast our billion actors. What happens next? What happens when you actually put them to work? What kind of scripts can they actually write for us?
Well, for instance, the researchers gave the AI the persona of a musician interested in audio processing. Then they asked it to create a challenging math problem. And what did it come up with? This really complex problem about analyzing audio signals with sine waves, a task taken directly from that persona's unique professional world.
And now for the jaw-dropping results. They took a relatively small AI model, only 7 billion parameters, and trained it on over 1 million of these math problems generated by the personas. That small model then scored nearly 65% on the super hard math benchmark. To put that in perspective, that's a performance that matches a state-of-the-art monster model like GPT-4 Turbo. This proves the data isn't just more data, it's incredibly high-quality stuff.
But it's not just about complex math. The personas can get really creative, kind of quirky, and, well, very human. Check this out. It's a Rougiba-style logic puzzle generated by an IT consultant persona. If I put the router in the refrigerator, will it improve the Wi-Fi cooling efficiency?
That shows a level of creativity and humor that goes way beyond just spitting out facts.
So what does this all actually mean? Let's zoom out. Having a billion digital actors on call isn't just some neat technical trick. It has absolutely massive implications for the future of AI, and for all of us.
This gets to the core theory behind the whole project. The researchers believe that a large language model is like a highly compressed file of all human knowledge. These billion personas then act like the keys to decompress that knowledge, to pull out specific information from every possible point of view and turn it back into useful, high-quality data.
The potential good here is just enormous. I mean, this isn't just another way to make data. It could solve the AI data crisis for good. You could simulate entire societies to test new products or government policies. You could even create a way to finally get full memory access to every single thing an AI has ever learned.
But, and it's a big but, this new power comes with some really serious risks, and the paper itself points them out. This method could be used for knowledge dumping, basically extracting the secret sauce from a proprietary model and copying it. It could completely upend the dominance of today's giant AI companies. And of course, it could be used to create an endless stream of misinformation that is almost impossible to tell apart from something a real person wrote.
And all of that leaves us with one final and pretty critical question. We've just seen how you can teach an AI to act, to adopt any identity it wants from a cast of 1 billion different characters. But if an AI can convincingly wear that many masks, can we ever truly know what's underneath?